Alright, this is lab report 3. In this lab, I solved for the mass of a black hole, which was orbited by a star. I then simulated and then I did another model of a orbit of a spaceship around a moon, which was orbiting a star. These are the two models of this lab, and the primary physics concepts in this lab are gravitational force and how it affects velocity and momentum. On the left is the code for my first model. This code simulates a star orbiting a black hole with a random orbit, which was given to me by my email. The code works by using a calculation loop to run through in each frame of the simulation. Then in each frame of the simulation, I split up the FNet components to analyze how the force of gravity changes speed. Then the code uses this data to guess, basically, the black hole mass using simulated values and using formula F_grav is equal to GMM divided by R squared, which then if you solve for the mass of the black hole, you get mass of the black hole is equal to FNet times R squared over GM. From these values, or little m is the mass of the spaceship. From the values, I found the average black hole mass using the code to be 7.5 E43 kilograms. So as for my visual, it's on the left of the model, or well, this is more visual given to me by my email, but the yellow ball is the star and the green circle is the orbit, black circle is the black hole. With the average mass at the bottom, there were a lot of values up here, but my code averaged them out. Okay, as for my model of the orbit of my spaceship, this code simulates a spaceship orbiting a planet after lifting off from the moon, with the challenge being that I have to design my model to avoid this ship hitting the moon. The code works by simulating the forces of the planet on the ship and the moon, and the forces of the moon on the planet and the ship, and then calculating how both the moon and the ship move. And then the code then checks if the ship is ever in the radius of the moon, and if so, then the code says it crashes. Some of the challenges with this code involved getting the speed of the ship correct. If too high, the ship would fly out of orbit, and if it were too slow, the ship would crash into the moon. I had to do a lot of guessing and checking to get this right. This is basically what it looked like. I had to stop it short, but the pink line is the orbit of my ship. It starts from here, this big, and then as it gets sucked in by the moon, it starts moving in here, goes around a couple times, and it really stays in this general area. So yeah, the blue circle here is the orbit of it. As for my analysis, and what does it mean? Question is, how do the components of net force differ from those of momentum over time? Really, the answer to this is that they are conceptually the same, but one is measured from data, momentum over time, and the other is found theoretically, of course. So in this lab, I observed the motion given to me by my email to predict the force that the black hole put on the star. And so I was able to use how the star moved to calculate the gravity of the black hole. I did not solve for the force and then predict motion based off the force, and that's the difference between the two. As for our what if question, what if this imaginary system has a black hole, a star, a planet, and a moon? First of all, I have to say that this would be quite challenging. There would be a lot more variables, a lot more things to add up, and honestly, that would not be fun. But you know, maybe we'll do it. But I would have to find the effects of each body on each other body, and although doable, I don't think I would have a great time doing this, but there would of course be some dominant forces in the system, right? So since force is directly proportional to mass, the bodies of objects with more mass are going to have a greater effect on the system. So the sun, the black hole, and the planet are going to affect the ship a lot more than the ship is going to affect the black hole. Anyways, that's my lab. I appreciate you for listening.